lemma 1.3.3. This singular integral is obtained by eliminating P and Q from the equations. F of xyz peak is equal to 0, Fp of xyz peak is equal to 0, Fq of xyz peak is equal to 0. The main advantage of this lemma is we can find the singular integral of a given PD without knowing the complete integral. This is the main advantage of this lemma. Proof. We have the PD f of x, y, z, p, q equal to 0. And we have seen that let z is equal to f of x, y, a, b be the complete integral of mark it as equation number 1. Z is equal to f of x, y, a, b be the complete integral of equation 1. And we know what is small p. Small p is equal to dou z by dou x. That is, differentiate this z with respect to x means differentiate f with respect to x partially. That is, fx of x, y, a, b, and q equal to dou z by dou y, that is equal to fi of x, y, a, b. Then we can write equation number 1 as then equation 1 becomes f of x, y, and z is capital F of x, y, a, b, and p. P is equal to fx of x, y, a, b, and q. Q is fi of x, y, a, b equal to 0. Mark it as equation number 2. Equation number 2. Now I am going to differentiate this equation number 2 with respect to a. For that, let us consider the diagram. We have f, and f has the variables. F contains x, y, capital F of x, y, a, b, then fx of x, y, a, b, fy of x, y, a, b. Now I am going to differentiate this equation number 2 with respect to a. That is, differentiate equation 2 with respect to a. We get, that is by chain rule, we get dou f by, and what is F F is set. F is set. What is Fx? Fx is equal to P and Fy is equal to Q. So dou F by dou Z into dou Z by dou A plus dou F by dou P into dou P by dou A plus dou F by dou Q into dou Q by dou A equal to 0. That is, we just differentiate equation number 2 partially with respect to A. Then this can be written as, this is F set, and what is set day? It's set day plus this is Fp and Pa plus this is Fq and Qa equal to 0. And we know one more thing is that, what is P? P equal to dou Z by P equal to dou Z by dou X. Then what is PA? PA equal to with dou P by dou A. That is, PA is notation for differentiate partially P with respect to A, which is equal to dou by dou A of, what is P? P is dou Z by dou X. And what is dou Z by dou X? Dou Z by dou X is same as Fx. That is dou by dou A of Fx, and which can be written as Fxa. That is, Pa equal to Fxa. Qa, we know Q equal to dou Z by dou Y. Dou Z by dou Y. And Qa equal to dou Q by dou A, which is equal to dou by dou A of Q. Q is dou Z by dou Y. And we know dou Z by dou Y is Fy. This is Fy. It is dou by dou A of capital Fy. So this can be written as Fya. Because of these two results, we can write this as F set into ZA plus FP PA. PA is Fxa plus FQ into QA. QA is Fya. y a equal to 0. Mark it as equation number 3. Then differentiate equation number 2 with respect to a. Differentiate equation 2 with respect to b. We get dou f by dou z into dou z by dou b plus dou f by dou p into dou p by dou b plus dou f by dou q into dou q by dou b equal to 0. This is f set into zb plus this is fp into pb plus fq into qb equal to 0. This is f set into zb plus fp into pa equal to fxa. So pb is equal to, by the same method, pb is equal to fxb. This is capital fxb plus fq into qb. qb will be fyb. fyb equal to 0. And mark that's equation number 4. Z is equal to capital F. We know equation number 3. Okay. This can be written as f set ZA. We know Z is equal to capital F. So ZA means capital FA. F set into capital FA plus this is FP, then FXA plus FQ, FYA equal to 0, and this will be F set, and this is capital F is equal to Z. So ZB will be capital FP, capital FB plus FP of FP into FXB plus FQ into FYB equal to 0. And this is equation number 3, and this is equation number 4. Since Z is complete integral, by definition of complete integral, FA and FB are 0. Since Z is equal to capital F of X, Y, A, B, 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 complete integral, FA equal to FB equal to 0 by definition. By definition of complete integral, FA equal to FB is equal to 0. So this will be the equation number 3, and equation number 4 will be, so equation 3 implies F equal to 0, so F set into 0 equal to 0, and this is fp fxa plus fq fya equal to 0 and fp fxb plus fq fyb equal to 0. That is equation number 4 implies. That is, we have two equations with two unknowns fp and fq. That is, we have two equations with two unknowns fp and fq. Since f is complete integral, by the definition of complete integral, it is clear that determinant of fxa, fya, fxb, fyb is not is equal to 0. That is, since f is complete integral and f equal to f is equal to 0 by the definition of complete integral, and we know z is said to be complete integral if the matrix f fa fxa fya fb fxb sorry fa fxa fya fb fyb has rank 2. By using that definition, we will get determinant of fxa, fya, fxb, fyb not is equal to 0. Consider this is a homogeneous system of equations because RHS is 0 and number of unknown is equal to 2, and this determinant is not is equal to 0, which implies rank of this matrix is 2. That is, we can write this system, equation number 5, we can write equation 5 as ax is equal to 0 format. That is, fxa, fya, fxb, fyb into ax. Here the variables unknowns are fp, fq, fp, fq equal to 0. That is, we can write this system as in this form, ax is equal to 0 format. Since determinant of this matrix is not is equal to 0, implies this matrix has rank 2. This has rank 2. The number of unknown equal to 2. Since rank is equal to number of unknown is equal to 2 and this is homogeneous system, this system has unique solution. I repeat, this is a linear algebra result. Since, and we know a homogeneous system has always a trivial solution. This is a trivial case, and if the rank of this matrix equal to number of unknown, then this system has unique solution. unique solution, and that solution is the trivial solution. Trivial solution means fp is equal to 0 and fq is equal to 0. We have this matrix have rank 2 and number of unknown is equal to 2. That is, rank is equal to number of unknown, and also the given system is homogeneous, which implies equation number 5 has unique solution. Equation number 5 has, therefore equation 5 has unique solution, and that solution is fp is equal to 0 and fq is equal to 0, and that is fp equal to 0 and fq is equal to 0, which implies we can obtain the singular integral of the given PDE f of x, y, z, p is equal to 0 by equating f is equal to 0 and fq is equal to 0. That's the lemma. That's the proof. That's the proof.